Hello. In this episode, we're going to talk about solving rational equations. The general steps in solving irrational equations involve the first, we determine the domain. And the second step usually is solving. The last step is checking. Okay. Sometimes the numbers you get may not be the solution or is not in the domain. Take the first example. The first example, we have rational, rational, rational. What this statement says is if the left-hand side is equal, the same as the right-hand side. So first thing we need to know that we need to make sure we work in the domain. In the domain means that every expression is guaranteed to happen, to be meaningful, and the denominator cannot be zero in this case. So the first step, we need to factor all the denominators. As it happens, we know that x squared is equal, x squared minus 1 is x plus 1 times x minus 1. And the other factors are x minus 1, x plus 1 as well. So from here, we can tell in order to guarantee all three terms, in order to guarantee we never encounter denominator equal to 0 situation, and then this must be set to be not equal to 0. Okay, so as a result, we can solve x squared not equal, x squared minus 1 not equals to 0. And solving this, we will get x squared cannot equals to 1. And the absolute value of x cannot equals to 1. So finally, x cannot equals to positive 1 or negative 1. So the domain would be x cannot equals to positive 1 or negative 1. So all the solutions we found cannot violate this requirement. So the secondly, we're going to solve. In the process of factoring, we have found something we call the least common denominator. So this is also called LCD. Our LCD is x plus 1 times x minus 1. So we can utilize this to simplify our equations. Okay. So what we do is that we're going to multiply this factor, this LCD, on every term of the three terms. We multiply the same thing on every side. Because x squared minus 1 is x plus 1 times x minus 1, therefore, there's a reduction here, there's simplification here. As a result, we're gonna get these simplified. The first term, we only have negative x squared plus 10 left. The second term, we have x minus 1 reduced. So we're gonna have 3x multiply x plus 1. On the other side of equal sign, x plus 1 and x plus 1 are reduced. So we have 2x multiply x minus 1. So by this time, we have all the denominators reduced. So now we're going to move our terms and simplify, right? We're going to expand. So negative x squared plus 10 plus 3x squared plus 3x equals to 2x squared minus 2x. Okay, so we get all of these simplified, and we're going to combine all the x squared term together. Okay. When we combine all these x squared terms, we're going to do one side at a time. Okay, negative x squared is 3x squared. So that will make it 2x squared. 2x squared on this side. Okay, plus 3x plus 10. On the other side, we have a 2x squared minus 2x. And 2x, if we subtract 2x squared on both sides, we will have only 3x plus 10 equals to negative 2x. If we add 2x on both sides, we'll have 5x plus 10 equals to 0. And if we subtract 10 on both sides, and we will have 5x equals to negative 10. In the end, we get x equals to negative 2. Once we get to this point, the first thing we check, we're going to do domain check. Domain check. Our domain is x cannot equals to negative 1 and positive 1. And x certainly is in the domain. Okay, so x minus 2, x equals to negative 2 is in the domain. The second check is ideally you will go back to the equation, check the left-hand side and check the right-hand side and check the left-hand side. The right-hand side and the left-hand side. Okay, with the number negative 2. So here you're going to have negative 2, x equals to negative 2. And over here, we're going to have a negative 2. And over here is negative 2. And over here, of course, negative 2. And negative 2 over here. So everywhere axes, we're going to check if that's going to make it left equals to right. So on the left-hand side, we put the numbers in place. Negative 2 squared, that's a negative 4. Because there's a negative sign there, okay? Negative of negative 2 squared. So this piece is a 4. There's a negative sign there. So it's a negative 4 plus 10. Denominator is, this is a 4. 4 minus 3 is, 4 minus 1 is a 3. Plus, and over here, oh, there's a negative 2 over here. X is replaced by negative 2. So this is a negative 6. The denominator is a negative 3. Now, the left-hand side is over here. That's going to be 6 over 3. 6 over 3 is a 2, right? And over here, that's already a 2. So this is a 2. 2 plus 2 is a 4. So the left-hand side will be equals to 4. And let's see what's on the right-hand side. On the right-hand side, we have 2 times negative 2, that's a negative 4. The denominator is a negative 1. Negative 4 divided by negative 1 is a positive 4. So when x equals to negative 2, the left-hand side indeed equals to the right-hand side. Then we can say is a solution to the equation. That equation, of course, is the original equation. If you write it down, that would be very nice. Okay, so you can make it. You can say thus, right? X equals to negative 2 is a solution. I will do another episode to do another example. Thank you for watching.